So now that we spent time yesterday evaluating expressions and really focusing on how do you take a given scenario or word problems as they've been called traditionally, and how do you write algebraic statements or expressions that represent that problem. And the whole goal there is to make it easier to understand. Remember, you could write that whole paragraph about the problem, or you could write a quick little math sentence that'll give you a little bit better idea on how to approach the solution. Today we're going to focus on a little bit even more useful tool called an equation. And I know you've done these before when you've done like 2 plus 3 equals 5. An equation basically is when you have two expressions that are the same. And we use an equal sign to show equality or to show that they have the same quantity. Again, we talked about this in the video previously. The difference between evaluate and solve. Now, before we were talking about evaluate, which just basically means take a number, plug it in. We are going to use this today. But solve is what we're looking for today. Figure out what value for the variable would make the two sides equal if you plug it in. So in other words, if I have an equation, what number will work if I plug it back in and evaluate it? So there's that word evaluate. We're going to use that, though, to check our solution. A solution is the number that if I plug it back in, makes the two sides equal, makes this equation work, makes it true. So if we're looking for an equation, say we have three options here. Now, keep in mind, this is not solving. This is evaluating. So if I have x plus 8 equals 15, if I plug each of these in, very obviously, you'll know which one works. If I do 5 plus 8 equals 15, notice I put the question mark there because we're testing it. We're not actually saying this is equal. If I don't put a question mark there, I'm saying that 5 plus 8 does equal 15. So 13, nope, that is not a solution. That being 5. So x equals 5 does not work. Next, we try x equals 7. Plug 7 in for x. Take that 7, plug it in here. You get 7 plus 8. Again, we're testing it. And yes, the two sides are equal when I do this math right here. Notice I didn't stop on this first step. I actually went through and did the math in my head to check it out. So yes, this is a solution. So x equals 7 is a solution. And x equals 23 obviously isn't going to work unless we did minus 8 and did the math incorrectly. So 31 does not equal 15. Okay, so that's not a solution. So just by plugging in, we can figure out. So we could guess and check, but that gets a little tricky when we get into some of the trickier equations we're going to see later in the lesson you're going to see tomorrow in class. So how do you go about solving? I know some of you have done this before. Hopefully this is a review for you. Think about what this actually means. I have this quantity n, and I don't know what it is. But I do know that if I add 10 to it, it's giving me 18. So what I need to do is I need to get rid of this 10. It's like a disguise. It's like one of those fake mustaches you wear. It's a disguise. And you get rid of that, and you can see who the person actually is. So if I'm adding 10 here, it would make sense to just do the opposite. The opposite of adding something is to take it away. So I'm going to take away this 10. And notice that gives me 10 minus 10 here is 0. I don't need to write the 0. I just write whatever remains on this left side here. So if I covered this up, if I covered up this left side here, of course it's not going to work. If I covered that up, all I would have on the left side here would be n. On the right side, I have whatever 18 minus 10 is. It's 8. So notice what I've done here. By taking away the 10, I've isolated this variable. I've gotten it by itself to show that it's actually 8. Now, checking that solution. This is an important process. Again, not quite as necessary here, but it's good to get in the habits now. So I'm going to take 8, and I'm going to evaluate this equation up here for n equals 8. And notice I don't just stop here. I finish with the 18 equals 18. Be a stickler on that, guys. Down here, this time I don't know what y is, but I do know if I take 11 away from it, I get 22. So the opposite of taking something away is to put it back in there. So if I add 11, that gets rid of that, and I have y remaining on the right. Notice I don't put y on the left. It doesn't matter what side y is on. 33 equals y is the same thing as y equals 33. That's called an equal sign. It works either way. So here, I'm going to test my solution by plugging in 33 for y. And I get 22 when I do the math. Sorry about that. 33 minus 11, I do the actual math there. I get 22 equals 22. That is a solution. Just like n equals 8 is a solution up here. All right, breezing through these next three. I do know, I don't know what x is, but if I multiply by 8, I get 32. Well, the opposite of multiplying something is to divide it up into little groups. So dividing it, I know I have 8 x's. I need to know what one of the x's is, right? So if I take my 8 x's and divide it into 8 groups, that's going to give me one group of x. 8 divided by 8 is 1. Notice the coefficient here is 1. When there's no coefficient, that's what we assume. More on that later. 32 divided by 8, 4. So if I have 8 groups of x, x plus x plus x plus x, 1, 2, 3, 4, 5, 6, 7, 8. That equals 32. If I have only one of those groups of x, well, that's going to be 4. That would be 4 plus 4 plus 4 all the way up to 32. So checking this then, I plug in 8 times 4, and my solution works. Notice, guys, I hope you're thinking about these things in your head and you're not just blindly doing the math. That's where a lot of people get in trouble. Down here, I'm dividing n into 7 groups. When I do that, I get 7. So I need to know what's the larger number that if I divide it by 7 gives me 7. So the opposite would be to multiply by 7. So when I do this, that gets rid of the 7's, leaving me with n. 7 times 7 is 49. Check the solution. Make sure it works. There is no reason why you should miss any of these problems if you actually stop and do the math. 49 divided by 7, 7 equals 7. The only way you can possibly miss these is if you don't do the check step. Especially when we get to problems like this. Now, think about what's happening here. Let me cover up this bottom one so we can focus here. What's happening here is I have 3 groups of y, but I also take away 7 from those 3 groups. If we're just 3 groups of y, I could very easily just divide that up and figure out what one group is. But by taking 7 away, I'm complicating the process a little bit. So what I need to do is I need to get rid of this 7 here. I need to add that back. So I get rid of that so I can figure out what 3 groups of y equals. Now, this might seem a little counterintuitive because Aunt Sally says to do multiplication before subtraction. But if you think about what's happening here, whoever wrote this problem, they multiplied and then subtracted 7. We're doing the opposite, right? So when you are solving an equation, it's like you're unwrapping it. It's kind of like when your mom gives you a present. Well, she doesn't put the bow on first. She wraps the present in wrapping paper first. That would be like multiplying by 3. And then she puts that annoying little bow on that's impossible to get off. Well, if you want to get to the present, if you want to get to y here, you got to get rid of the wrapping paper, yes, but you're not getting rid of the wrapping paper before you get rid of the bow. So you got to get rid of the last thing she put on. The last thing that was put on here was this 7. So once we get rid of that, we're good to go. So I have 20 plus 7 here is 27. So now I know that if I do have 3 groups of y, it's going to be 27. So what does one group of y equal? That's 9. Again, no reason to get these wrong if we now go back and do a check step. 3 times 9 minus 7 equals 20. Let's see if that works. 3 times 9. Now we are doing order of operations because now we're actually multiplying. Notice I'm not done here. I still need to do 27 minus 7 is 20. And it checks out. This is a correct solution. All right, let's try down here. Now what I have here is I have this number divided into 9 groups. But then I also add 5 to it. So what do I do first? Well, I have to subtract the 5 out of there so that I can focus on what's happening with this division. I can't focus on that until I get rid of this little distraction here. Okay? Now, 1 minus 5. Hopefully you've seen that before. Just a little preview of things to come. Negative 4. Okay? I tell you what, I'm going to change the problem midstream, just so we don't get too confused here. Let's change this to 11. Okay? So we're still going to subtract 5. Some of you should be able to do that problem. But now, we have 11 minus 5 is 6. Okay? So when I take my big group and divide it by 9, I get 6. Well, what does the bigger group equal then? It's going to be B equals whatever 6 times 9 is. That's 54. Okay? So let's check it then. Let's make sure we have the right answer. So we're going to take 54, plug it in for B. So let's see. If I take 54, divide it by 9, and then add 5 to it, do I get 11? Well, 54 divided by 9 is 6. So I'm left with 6 plus 5. I need to actually do the math in my head, even though I wrote it over here. This is 11 equals 11. Check. This is a correct solution. These two-step equations are a little bit trickier, but only because you've got to peel away 2 different layers. But remember, as long as we're not doing, as long as we do SADMAP when we solve, we're good. Notice that's the opposite of, please excuse my dear Aunt Sally. So, for homework tonight, we have 5 problems here for you, plus a word problem. On this, I want you to write an equation and solve. And we're going to talk about your solutions tomorrow and your equations tomorrow as well. Take your time on that. You also have your journal prompt about what this video meant. Make sure you address the questions that you need to in that. Good luck.